Hello. Why is this not going? Because it was not going. Okay. Hello. How's it going? So, we're going to do something almost a little bit formal today. It's been a while since I did a thing that could get posted on the YouTubes as a highlight or whatever. So, we're going to do something like that because there was a little bite-sized thing that I might, if it goes well, right? If it's theoretically a simple thing, but if it doesn't go well, maybe we won't post it. I did some changes, I think, today that I want to check in. Let me see. Did I do anything significant? Not on source. Okay. No, I hit the wrong button. Trying to implement high-speed USB drivers in Windows. That does not sound like a good time. In fact, it sounds like the exact opposite of a good time. I'm just going to say. Just gonna say that. I'm gonna drink a little bit of caffeine, and then we'll start the thing that we're gonna do. Fix that. Fix this. Do I plan on allowing the camera to zoom in farther? No, there's no reason to do that. No, 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 no. Looks like it's all coming together. It is coming together. However, all coming together is, let's just say there's a lot. There's a lot. And so why is there a fly in here, dude? There's never flies in here. Get out. Get out. Get out, foul creature. You had some guy come into your Discord to complain about your game's new direction. Yeah. Yeah, everybody's an expert in what you should do. All right. Getting there. Cup, little more hot liquid. And then I'll explain what we are doing. Don't fly. Get out of here. Seriously. Okay. So let's check camera aiming this. It's pretty good. We can turn on the magic lamp, except we have moved it again. It is not really visible right now. It is behind me. And probably below. No, it's there. It's just off. Today I thought I would do a little bit of camera work that I've been trying to get done probably for a week now. I don't remember. I talked to Casey Muratori about what problem I was having, and he suggested a solution that sounded pretty good to me. And I've just sort of been waiting to do it because there's just so much to do on a video game. But it's Sunday night at 9:15 p.m., which is the perfect time to get something done that is extra. So let me explain the problem. In this game, right, you walk around in a view somewhat like this, where it's kind of overhead. This is more overhead than it often is. Actually, as I go out further away from the camera, right, because it's a perspective camera, it gets a little more side on. But that perspective changes from level to level, like the number of squares that we're focused in on, so to speak, changes based on the level that we're playing and all that, right? Okay. So that's the main view that you play in, right? There are other views. So, for example, if you're here on the overworld and you want to see everything, like I need to reorient myself. I need to know where I am in this huge level and what's going on. You can do something like this, right? And we pop you out to the overhead view. This is a continuous camera transition, right? We're not like fading in some other thing. You can actually see objects moving down on the south side of the map, and those are the legit objects moving the legit way that they would. And, you know, that's a little bit of a technical flex to be able to do that. Like a lot of games that are intended for this kind of view would completely fall apart if you did this, right? So that's nice that we can do it. Now, of course, as you can see that a lot of it's really blocky and doesn't have real art yet. We're in the process of spreading the art out to the whole level. And the goal is to hit a good frame rate, while you're looking down on everything. And I think we've done all the really deep technical stuff that's necessary for that to happen, but we'll find out as we add this stuff. Okay. So that's one view. Now, this is a little bit far out. In fact, this is far enough out that we actually don't let you actively play the game here. We ignore your input. And the reason is just, well, there were some other reasons originally, like maybe we wanted to commandeer some commands. So spacebar normally in the game shows you what level you might be going into if you stand on the level and press spacebar. Here you can use it to fade area names in and out, which is like a nicer way of looking at the map. So it lets us commandeer those controls, but also the game would be unplayable at this scale anyway. And I'm thinking that looking at this on like a 17-inch monitor, right? If you're playing this on a phone or a Nintendo Switch 2 or something like that, it's going to be a lot smaller even. And so, yeah, we don't want to encourage people to play at that scale, but sometimes you want some fusion between these two things, right? So sometimes you want to be able to play, but you want to be able to see more than one screen just to get oriented. And for that, we have this intermediate level view that shows like the local area. And we do let you run around in this view, right? Okay. So, and then, basically you toggle these. So you can see up in the upper left, when I press Q, I go into the local area view. And when I press tab, I go into the full view, right? And those are fully continuous camera transformations. Now, one other thing to say about this is this is not driven by a dynamic controller for reasons which I'll say in a second. Well, actually, okay, let me switch around the way I'm explaining this. So in a game like this, you want to be very responsive, right? When the player does things, you want to respond to those things. So these controls are toggles. Let's say I start going into the overhead map and I was like, wait, I didn't mean to do that. I fat fingered that, right? You shouldn't have to wait all the way till here and then go. Now that is pretty fast. That's a lot faster than like opening a window in Windows 11 or something, but still you might change your mind faster than that, especially if you're a gamer. And so you can stop in the middle and it'll reverse, right? So I'm stopping anywhere along this. Now note also, it's a little bit subtle, but there's an easing function on this. It's not a fully linear, like 0 linearly to 1, right? We'll talk about this in a bit. There is a parameter that ranges from 0 to 1. 0 is fully in and 1 is on the overhead map. But we then put it through an easing function. So it's just slower at the end, I think, right? And I don't want to do this right now, but if you don't believe there's an easing function, we could go in and change it and it would look worse, right? Because it would like be going out and then like hit a wall. And we don't exactly hit a wall, we like slow down. Okay. So the reason we do things that way is because it's very easy. So, well, and very deterministic, let's say, to pick a term that I got in an argument about with someone on Twitter lately, right? So when you start doing nonlinear things, like say you program some like camera physics that tries to accelerate and decelerate in order to provide easing, that's going to be frame rate dependent unless you're really careful about it and know a lot of math, which most people don't. And even if you do, it can be hard to do it without it being buggy and all these things, right? So instead of that, right, like and you can have all these problems that controllers have. For example, like you're aiming toward a target and then the target changes and you're going too fast and you go past it and you have to oscillate around it trying to converge and all these things. These are all known problems with controllers, right? And you can solve them, but it's hard or it's laborious or both. So this is a very simple system where you start at 0. Every frame you go so there's some time that the transition is supposed to take. Let's say it's 1 second to go from 0 to 1. It's about 1 second. I don't know. It's maybe a hair longer than a second. I don't know. So there's some time that it takes, and then every frame you just linearly progress from 0 to 1 or from 1 to 0, right? And because it's linear, you don't have frame rate dependence in the sense that, like, yes, if you have more frames in the intervening interval, you'll stop at more points or different points along that curve if the frame rate's jittery and all these things. But at time t, you will be t amount of the way between 0 and 1, regardless of what happened on previous frames. And that's very understandable. It's very controllable. Or I shouldn't say controllable because controller, it's like anti-controller. Okay, so that's the groundwork. And then, so if I start here, we could slow it down a little bit. If I start here, oh, that's not slow enough. If I start here and I'm going out, right? Maybe you can see the easing this time. Yeah. Let's say I'm going in and then I change my mind and want to go out again. So I'm going in. Oh, right. So we just reverse the direction of the target. So if I start going in, it's like, oh, the target is 0. And then I tap it again and it's like, okay, the target is 1. All right. Now we don't have any easing on the reversal here. That's instantaneous and hard, but like you kind of don't want slop like there like this happens so fast anyway that you would rather it feel responsive than feel sluggish. And I think if we had to put acceleration in there, we wouldn't be able to do our very deterministic solution anyway, right? Okay. So that's the background. And then going to the local area map, which I don't know if I use that name, but that's what I call this. It's confusing. This is the close-up map, right? This is the local area map. So going here is the same thing. It's just a different parameter. This is called local area T, and that T is a thing. That's my name for the parameter that goes from 0 to 1 always. Some people use S for that. Some people use U, like whatever. But for me, it's T. So local area T, because I like to drink tea, goes from 0 to 1. And overhead map T goes from 0 to 1. Now, what happens, because you want to respond to the player, you want to be able to go into either mode from either mode. So I go into this mode, and then I want to go into local area instead of coming all the way back to the main view, the close-up view. So I can do that. I can hit Q here, and we just go here instead of all the way back. I could hit Q again, right? Or I could go from Q to the outer map, back to Q, to the full map, whatever, back to Q, back to the full map, back to Q, right? I can do this all I want. And now here's the thing though. What happens if the transition, well, okay, how does this work, right? And the answer is we blend between all these things. This transition's a little bit not smooth sometimes, which is interesting. I actually am not sure. See that little bump in there, that little wavy gravy that's happening? Wait, let's do that again. See that? It doesn't seem to happen all the time. I'm actually not sure why that's happening. Even simple camera systems are fraught with peril. Okay. So here's the question. You want to be maximally responsive to the player. So if I'm starting to go to Q and I'm like, no, wait, I changed my mind. I want to go all the way out. I can do that. And it works. However, did you notice there was a little bit of a bounce there, right? Let's do that again. I think in the other direction, the bounce is even more obvious. Say I start and I'm like, I want to go all the way out. Wait, I want to go local area. So I tap Q. See that? We came in too far and then we came back. What's happening? I just said we're not using a controller, so we shouldn't be overshooting and all that. But the way that we're achieving this is we're blending all of these together, right? So the code starts with this. It computes for this frame, what is the camera position and orientation? And it does this with a look at point. Like the parameters are like, I'm looking at the center of this room, right? And I want this many squares to fit in my view. And that just tells you, and the camera's up from above looking down. You have a few constraints like this, and it tells you where the camera goes, right? And that's fine. So you can compute that. And then of course, this, how do we do this? Well, the camera's further up, but this is also a very close to an orthographic view, right? You'll see if I slow it down, the perspective starts to go away as we go up, right? And how do you do that? We're actually going up way higher than it looks. But at the same time, we're squeezing in the field of view to be very narrow. And that, if you were to do that infinitely, if you were to go infinitely far away and squeeze your field of view to epsilon degrees, then you would be perfectly orthographic, right? And that's how you can create a continuum of projections between these two styles. Now, for this game, we don't necessarily want to get rid of 100% of perspective. Here we almost do, but in some levels that are closer in, we'll have overhead views that leave a little bit of perspective in there, but they're close enough to orthographic that you can see, like in plan, what is on top of whatever else, right? And that's a fun stylistic thing that we can do, right? Okay. So, is there anything else that I need to explain before we talk about the bounce? I sort of derailed myself in that discussion. Anyway, though, so what? Oh, right. I was explaining how we do it. So there's a camera position and orientation for this. There's a camera position and orientation for this, and there's a camera position and orientation for this, and we blend them together. The way we do that right now is in sequence always. So we always start with this, and then we blend to this, right? And usually it's either 0 or 1, right? So if we're here, then we're blending that overhead map view, but we're blending it with a factor of 0, so nothing happens, right? Similarly, for this one, it's a separate track, right? So we're blending from the local view to this, and that's 0 to 1. And then the way that we get this ability to transit between these is that we cross blend between them. And the thing is that I think it's the way that we're doing the cross blend is causing the bounce, because so when I'm in here and going to the overhead map, right? Overhead map T is 0, and now it's going up, and now overhead map T is 1, right? If I just go from here to local area view, overhead map T starts going down from 1 to 0, and local area map T starts coming up from 0 to 1. That might actually be where that little wave comes from, is because these things probably even complete at different speeds right now because I was tuning them in weird ways, right? So if I do this, local area map T is going from 0 to 1, and global map T is going from 1 to 0, right? And of course, we can set those targets differently at any time. And so you can jerk the camera around all you want, and it'll end up in one of these places. Okay, so the way that I blend, let's try to, it takes so long for this to come up. It's like I've double clicked on it because I thought it didn't work, and then it goes down again. All right. So the way we do this is we actually have I don't know if this is going to be enough pixels. It's whatever PBrush is, but oh god, it's so laggy. We're going to exit the game for a second so that we can draw in PBrush, all right? Sad. Okay. I think I had this problem before too, I remember. Okay. So here we have this is let's make up letters for each of these. Let's call this G for the ground view, or no. Let's call it C for close, or let's write close. That's pretty good. All right, that's close. And this is area, let's call it, right? And then we have some, does it do shift? No. We have some parameter, area, I'm drawing with the mouse, area t, that tells us where we are between those, right? And at the same time, we have overhead. Let's call that just overhead, right? This is the far away overhead. We could call this global or something. I don't know. I've already written overhead. Just remember, area and they're all kind of overhead views. That's yeah. You know what? Let's call it global. That's going to confuse people who think about variables. It's fine. Global. All right. And then, wait, that's not global though. I'm silly. So this is again close, right? And this is global. And this is global underscore t. All right. So yeah, we could have called them close, medium, and far in hindsight, but I've already named them. Okay. And then, so we do these interpolations separately. And then we blend between them because they output the same thing as they inputted. And so here we blend. Actually, this is not even true. Now that I've written this out, this is not even actually what I need to turn on my brain when I do this. All right. Actually, what I do, okay, let me just say you could imagine this. This would be one way to solve the problem, right? You blend, and then you cross blend between those. I think that would probably still bounce. But as people know who do blends, there are different ways of blending things, right? This isn't actually what we do. Instead, what we do right now that is also causing a bounce is let's pick some point in here that's the result of our interpolation. Like I said, it's usually at the end or the beginning, but let's say we haven't finished. It's here. And then we say, I'm going to go to the global area map. We actually blend this way. All right. Let me erase this because it's probably confusing. By erase, I mean draw white over it. Okay, so this is what we're doing right now. Okay. And so the thing is, this interpolation represents a very large camera distance, right? So let's put another dot on here because this dot is also going back and forth, right? So, and let's draw little arrows on the arrows. All right. So this dot is, this dot's going up because we're going from 0 to 1. If this is going from 0 to 1, this one's going from 1 to 0. All right. So this, I shouldn't have drawn this arrow in green. My apologies in advance. This is going this way, right? And then we're blending these two results. And so when this interpolation is done, this has gone to here and this has gone to here. And so we end up at area, right? But this makes a triangle, basically. You can, let's pick another color. You can see that there's like a triangle of all the results that we could do. And we're basically moving around in that triangle. This point, right? This T determines where the point is along this edge. And then we go from this edge toward this point. That always gets us where we want to go, but where are we in the middle? And does it matter? And like, yeah, sometimes it matters. And we're not doing that good of a job of controlling that. And the reason why it matters a lot is that, so this interpolation represents a large distance and this is a shorter distance. And so if this falls faster than this rises, or not even, how do I say it? Because it's not even, does this fall to the edge of this segment faster than this rises to the end of its segment? Because these are different distances. So like if this is 10 times as far, which it is, it's something like that. Then if this goes a 10th of the way in, that's more distance than going a 10th of the way up. And so you've brought the camera down, and even though this is bringing the camera up, it doesn't bring it as far. And so you get this bounce. Now, you might say, you're such a silly person. I'm going to ban you. So somebody says a comment which I'm sure they think is innocent. They say, okay, you're lucky I can't ban you because Twitch, it says failed to load module when I clicked on your name to pop a thing up, and there's a little Pac-Man ghost. You can't see because it's on my other computer. I hate the idea of rubber ducking. I think that idea is infantilized and dumb, and that's not what I'm doing. I'm explaining to you what I'm working on, okay? Like, yeah, sometimes once memes get into programming, they like poison everything. I'm explaining what I'm working on so that we can have a nice video to post to YouTube, because we haven't done that too often this year. All right. Okay. So I don't even remember what I was going to say. Right. Well, there's different ways to interpolate. You could have done what I did initially with these black lines. So if we were to do that, if I just sketch over here, again, what that, because this is a lot of lines already. So if I were to do the thing I started to draw, then you would have one interpolation, right? And then you would have another interpolation. Actually, let's not draw the arrows there yet. So this is like a line segment that goes 0 to 1, right? And then your green would be going up, right? And your red would be going down, right? And then, I mean, this line is green here, but let's pick a different color, cyan. So, and then you would blend between these, right? That's another way to do it. Then, okay, so this is interesting, right? This case always sweeps out a triangle, because we always interpolate here to here and then there to there. This line is kind of misleading here. All right. Let's scribble it out for a second. It's just, let's say in this diagram, this line is conceptual. You could interpolate this way. We don't actually do that. So when you're in the close-up view and you go to the global view and you didn't tap the area key, we actually are going this way. It's actually the same thing, because the length of this edge is 1 and the length of this is 1. But it doesn't look like the length is 1, but it is, right? But for the purposes of this diagram, you know. Yeah. Okay, this is another way to interpolate. I don't think this will avoid a bounce either, for the same reasons. It might have better behavior, broadly speaking, because here your result can actually be sort of anywhere in the square, except that's not really true, because the positions of the dots, are correlated heavily, right? And so if you were to sample where it is at any time, I don't actually know what you're going to get. But mathematically, this sweeps out a square. And that's kind of interesting, because maybe you're less squished in, so you're less likely to be near a weird ripple, right? Or a weird singularity. Maybe. Who knows? I haven't done the analysis. But, oh, is that under the camera at all? No, thankfully. I did it right above the camera. Many years of streamer experience right there. Okay. So what Casey suggested and what sounded like a good idea to me is to do the following thing, which isn't going to look that different from this one, but I think it is, right? So it's going to be every frame you interpolate between area and global. That is not a 6, that's a G. All right. You interpolate, let's just keep picking different, we're going to be out of colors in the MS Paint, but you interpolate between area and global to get a point. All right. And then from there, you always interpolate. Well, you can do this in either order because, you know, it's linear, but from there, you interpolate to your close-up, right? This also sweeps out a triangle like this. Okay. But I think it's a much better behaved triangle because you're never fighting between these two, right? You're always deciding how far out the camera should be, and then you're interpolating down to the bottom. So I think this will be smooth. Am I sure about this? No, but it looks to me like it'll be better. Now, oh, the other thing I was going to say, you might say, hey, Mr. Streamer, since these are just essentially 2 points on essentially in a line, like if you're talking about how far up is the camera, then why isn't it conceptually a line where you have close, right? And then you go to area, right? And then you go to overhead, right? And if you're at overhead and you decide to go to close, you actually go all the way this way and you pass through area. That would solve this bounce problem as well, but the problem is it forces this interpolation to pass through the area interpolation, and I'm not sure that's good. But I don't know. I don't know. I don't know if this would present visually. Oh, there is a problem with this actually, which is because remember, these are not totally linear. They have easing functions on them, right? So the problem is if you're gonna, let's draw with a mostly linear start, you're gonna have to use your imagination for what I mean by this. But like, here's our easing function that takes us to area, and then here's our easing function that takes us to overworld. It's not quite like, I think it goes further linear before leveling off, but whatever, right? You start out fast and then you slow down. You start out fast and then you slow down. So if we're going to keep our design and not use a dynamic controller, if you went from overworld to close, you would have a velocity bounce, which might look really bad, right? Because you're going through this this part of the easing function for the local area. You could try changing that, but now all of a sudden you're doing dynamic stuff and things aren't necessarily predictable. So like what happens? So instead of this, you could say, well, if I'm at overhead and I go back, I'm going to do this, right? And it's like, okay, but then what happens if you hit tab to start going back, and then right here, you hit local area view, right? The problem is you're right here in parameter space, but like in XYZ, like space, this point does not correspond to this point anymore. So you can't just say that that's your T. You would have to like solve for it. And what if you're in the middle of this easing curve and you have a discontinuous velocity and stuff? maybe that doesn't look awful. We do have discontinuous velocity when we turn around in the middle, but it's discontinuous from fast to fast. Discontinuous from fast to slow might look worse. I don't know. You could, if you were so opinionated, you could try to solve this in this fashion. And it would be a reasonable thing to try, but when I thought about it, I didn't like it. And the other thing about this is the more stylization you want to put onto the thing, the more problems you might introduce later after you thought you were done, right? This is a common thing. Like as you get close to shipping a game, you want to make it nicer and nicer and all these things. Okay, so with this one, the magic of this is that these two things, this black branch on the left, which goes from close to A, and the black branch on the right that goes from close to global, these can be any function and it doesn't matter because we don't ever interpolate between these sides ever. So you could make them actually pretty fancy and it wouldn't matter, I think. Um, well, okay, here's what I would say. I mean, I've been speaking about this as though it were what we're doing right now. I just said you could make them as fancy as you want, but I don't think that you would have two interpolation functions, right? It's more like you have one function that can have style squiggles and stuff, and then it'll either be toward the left or toward the right. But if you wanted these to be different, let's say you want the easing on local area to be stylistically different from the one on global. It isn't right now, but you might want that totally as a thing that you're uh, finishing the game. Well, easing functions are generally polynomials, right? And it's pretty easy if you imagine this as being like a metronome that goes back and forth, right? It's pretty easy to continually morph a polynomial into another polynomial in a known way that has no surprises, right? Especially if it's like, I mean, probably it's something like this. Like this is one easing function, and then we want this one to ease a lot sooner. It's pretty easy to parameterize something that'll do both of these, and then you just pick which one based on how far you are, and it would all be continuous and probably have no bounces. Although again, who knows, right? Like if you're moving along this curve and you change it into this curve faster than you're moving, I don't know what happens. Let's just say that. It depends on what your curves are and the speed that you're moving. And so the question is like, how fraught with peril is this interpolation? And I'm not sure. Okay, so the goal today, and it might be 5 minutes, and it might be an agonizing long time thing. We might not succeed tonight because I'm out of brain juice or something, right? And it's just, I've been working really hard lately, and sometimes you're just out of juice. Some people never work that hard in their lives. I do. I run out of juice sometimes. So we're going to see how it goes. But I want to do at least make this intro to describe what we're doing. So people on YouTube, if there's no programming after this part, it did not go well. Maybe it will go well. Are there any questions about this, by the way, before we go on and do the LEET code? I'm going to grab a drink, which will take a minute, and you can type questions while I grab it. Does anyone think it will bounce? That's an interesting question. Did you consider using barycentric coordinates? Well, the question is not really what is the coordinate system. The question is what's the interpolation, right? Because, I mean, everything I'm doing here has barycentric coordinates. So let's say what barycentric coordinates is for people who don't know. If we have a triangle here, there's a thing called the barycenter, which is what happens when you say 1/3 of A plus B. Let's just call the vertices A, B, and C right now. If you have that, that's a point. It'll be around there or something, right? And you could try to interpolate from that. I just don't necessarily have reason to believe that that generates results that are any better. Maybe it would, but like I said, I mean, just saying barycentric coordinates isn't really, I mean, this interpolation has barycentric coordinates, so does this one, right? It's just your path through the barycentric coordinates is different, right? Now there is sort of I've never really done interpolation in barycentric coordinates, but I think the way that, I mean, maybe this just turns into the default thing anyway, right? Because each of these would go to 0 to 1, right? Or 1 to 0 or whatever. And I don't think by default that that's very different from what we're doing. But who knows? Like, this is a little bit of a weird diagram because, like I was saying, you never hang out here. This is, you only transit through this zone. You're usually at a vertex, right? You don't understand why you have to add the lerps together in the first place and not just lerp from whatever the current position is to the goal, because that's dynamic behavior, right? So here's the question. The question is, if you start here and you go here to the green spot, then I hit the key. Why don't you just go from the green spot to here? And the answer is because that's dynamic behavior and you end up in some space. So first of all, how long does this interpolation take, right? Now you're making a new interpolation. What does it look like? What should the easing function look like? You're kind of guessing based on the distance, right? It's a little bit confusing because when I think about this overhead global view, I'm not thinking that much about the area view, and the amounts of perspective are different, right? Remember, this isn't just distance. There's like a perspective trick and the look at points move and all this stuff. And it's just, it's maybe a little bit confusing, right? So your camera can start doing weird stuff that's hard to control. And it can start feeling very laggy because you're sort of guessing. Like if you make it take 1 second for each time, then, for example, like let's say you held the interpolation time fixed and you always said, we're going to interpolate from a point to the new target, and it'll always take 1 second, right? Then if I go to global and then I double tap, right? So I go tap to go down and then tap to go up again. Now we're going to take 1 second to go this far when we usually take 1 second to go this far. So the camera is going to go really slow and it's going to look like something you didn't want, right? And so that's why you have to guess, like, how long should it be? And that depends on your easing function. Maybe you do some integral of like, how far would we go in a certain amount of time if we were at this point of the easing function, and you solve for that. That might be hairy. It might not. I don't know. Um, is there no way to draw it in any way that can save us from trying to implement a definite bounce solution? You might be able to do that. The problem is it's a little hard to visualize. So the state space of this, I think you would blow it out into a 3D shape, right? Because you have sort of 2D defined by these interpolations. But then you have a third dimension by how much are you interpolating. But it's actually sort of here it's sort of 4D because we're changing these two values independently. But those other two dimensions of the 4D are heavily correlated. And so trying to visualize that seems hard. But if you could, then you would be like, yes, we want to make sure that there is no path through this shape where the distance to the camera is non-monotonic, right? You don't want to look for, you would look for ripples in the shape, which you could probably do. You could probably with calculus determine that or something. Am I going to spend a month trying to do that? No, because I actually have to be productive. It seems like a lot of people don't understand why I am setting these requirements of not having a dynamic start point. And all I'm going to say about that is just it's from experience. Okay. You might think, oh, just interpolate from the dynamic start point and just, you always end up with something that kind of sucks when you do that. Now, that is a viable path towards solution, is to do that and then observe the cases where it kind of breaks and then tune it very heavily. Spend a lot of time like, oh, we have a little heuristic of how long the interpolation should take and all that based on what, because remember, I mean, I'm drawing this as a point along the line, right? But the value is a vector of not spatial coordinates, right? The value is some camera distance, right? Some FOV for the camera and some look at point that's like X and Y if we're going to draw scalars. And these can be tuned, like these are not necessarily proportional to each other, right? For these two targets. Okay. There might be, I don't know. You can imagine adding other parameters to this, like maybe there's a fog amount, right? We already have an F. We're going to call it, say, G for fog. Whatever. You can keep adding parameters as you do this. And so it's not like we're interpolating a 2D point through space. We're interpolating this to this D1, F1, LX1, comma, one looks like a comma, sorry, LY1, comma, G1, right? So this is what we're doing. And so if you ask, why don't you just do this simple thing? It's like, well, because, right? So for example, let's say because the FOV function is different along this edge than it is along this edge, for example, you could be going here and then you change your mind and you start going here. And D could be, 0.5 of the way to D1, right? But F could be maybe only 0.3 of the way to D1, right? Because the parameters are just closer here, or whatever, however you want to think about it, right? And so now you're interpolating with D and F1, or D, just say D and F are going at different rates relative to each other than they normally would if you just went along this line. Okay. If you have never seen what I'm talking about, you haven't done enough video game programming. You go sit in the chair and type code. Okay. I mean, dude, I was dealing with this problem after like 1 year being an industry wannabe or less. So like, this is not really that advanced. This is the kind of thing that you run into pretty early on, honestly. Someone saying, I saw this problem for a 2D game with scale and center, fixed it by changing it to a view rectangle instead, so it was essentially one variable to interpolate instead of two. Yeah, I mean, if you can do that, that's a viable solution for sure. There are a number of ways to solve this kind of problem. I wish I knew how to better describe, like, the only thing that I can think of to further describe this problem would be to like go off for a few days and make a sample program where it looks screwed up and then go through the different fail cases with you guys. I don't have time for that. I got to ship a game. Sorry. This is free. This is free content. You get what you get. Buy my course on Substack. Like and subscribe. Okay. Let's go to the code. I hope it's updated. Yeah, great. Okay. So this might go badly, guys, because like I said, I'm kind of out of brain juice. I also have an air conditioner that's either too hot or too cold, so I keep toggling it. All right. So here we go. It's a little bit more complicated than what I explained, only in terms of implementation details. So prior to this point, we have computed the close-up view, and we've put it in these variables, viewpoint and look at. And then the FOV comes later, actually. I drew this multi-dimensional vector for FOV, but because I want to simplify things for now and just get them done very well, FOV is actually a dependent variable on the up distance, which is fortunate because we're actually gonna still want that to be that way. Anyway, there's also fast travel mode, which we didn't talk about. That's a whole other thing, so you could ignore that. But basically, we have an if statement here because we want to interpolate toward pause area and area look at, but only if they're initialized, and they might not be initialized because there might not. There's reasons why there might not be a reasonable thing to initialize them as, having to do with how the local. I don't want. It's not actually that complicated. It's not, what would I say? It's not like theoretically advanced or anything. It's a very everyday plumbing kind of thing, but like, let's not go into it. We've already been talking for a frickin' hour. just explaining things. Okay, so here we go. Like I said, there's an area T that goes from 0 to 1 linearly, and then area TT is that put through the easing function. And let's, so camera ease is some Franken function where I go x cubed. So x is 0 to 1. I go x cubed to like, I guess that's the ease in part is the x cubed. But then I put it through this, which is the ease out. And actually God only knows what happens in this case, but I can tune it later. Like, there's the website. What is the one that gives you a bunch of easing functions? You can just pick something from there. Like, you could pick a little classic sigmoid shape if you want a flat ease in and flat ease out or whatever. Easings.net. Yeah. So if you don't know what an easing function is, it's a very common way to go from 0 to 1. So all of these are little code snippets where you put in a value that goes linearly between 0 to 1, and it gives you out this shape. So if we wanted this one, right, then, you know, this is just some polynomial. I don't know why they're saying pow comma 5. That's kind of assy. But you know, that's what happens when there's JavaScript programmers, right? So cubic, you know, cubic is probably pretty reasonable. They're calling pow of 3. You are fired. You are fired. You're not fired because it's pretty cool to just provide all this in such an easy to use UI, but like, bro. Okay. Very useful website. Power of 3 could already be optimized out. Well, that's true. It could be. But the thing is, a lot of people are going to transliterate that into another programming language, right? Okay. So we're doing something like one of those. And I actually haven't graphed this to see what it looks like because it's not my main concern right now. Okay. So we have this area T and we do that interpolation. And then, like I said, we go from this along this green line to global. And we do that by using this overhead T, which also has been put through some easing function, right? Okay. So we want to change this. Instead of having an area T and an overhead T, we want to have an interpolant that goes between area and overhead and an interpolant that goes from close to far. So we can call them far T, right? Because one means far. And we can call it like area to overhead T because one means overhead. And the question is, what's the best way to do this? And I think we just go. Now there's some nuances, right? Okay. So right now, when you hit one of the map control keys, like when you toggle one of the views, then we look at, okay, what does toggling mean? If you're toggling the overhead view, it means look at the current value target, the current target. If the target is 0, set the target to 1. If the target is 1, set the target to 0, right? Same for area. Here, we want to do that, except We also want to check the far t, and if it's 0, also set the current value, because if you've got some invisible variable sweeping back and forth between local area and overhead, let's say it's on overhead right now, and you say, I want to go to local area, then you're going to start going from near t to far t, but far t is on overhead, and then you're sweeping overhead to local. And that's a different curve than you want. You just want to go to local from close up, right? And so you can just set, because you're at 0, you could set it anywhere along the line and you get the same result. So you just set it, right? Seems like all the easings need to end at the same time regardless of curve. Maybe. What I would say is that definitely matters in terms of velocity, right? You might be only C0 continuous if you end one in the middle of the other one. That's something that's actually hard to do in this kind of scheme, is to synchronize those. Because like I said, well, maybe it's not. Yeah, I need to think about that. I don't know. Okay. We're just going to do this and we're going to see what the results are. And if they're terrible, they're terrible. We're learning. You graph the x cubed curve. No, everyone knows what x cubed looks like. Oh, you graphed it with x cube inserted. I see. Let's go ahead and click on that link so people could see. Where was it? Yeah. So red is this easing function, right? And then this is that function with the x cubed in there. So it's got like kind of a slower start, rapid rise, and then a rapid deceleration. And again, is this the best one? I don't know. It's made more complex by other things too, like the fact that this FOV thing is happening and all that. There's a lot of other subtleties, right? So when we change the FOV, we're not interpolating degrees, because that makes something that looks kind of nonlinear in terms of how much you see, right? Because degrees, like if you have a projected plane and you're interpolating degrees, the amount of plane revealed is going to speed up as your degrees get wider, right? The spatial amount. And so if what you care is the spatial amount of what you see, then we actually interpolate that, and then we solve for degrees based on that. Okay. What if the camera has a destination in some concept of how fast to accelerate? That's literally the first thing I said. And I said that's the definition of a controller that tries to reach a target. And it's, you can do a controller, but it's like, it's a whole thing. There's entire fields of study about how to make controllers good. Okay. There's been decades of people working on that. Okay. Like if you've heard of fuzzy logic, the entire field of fuzzy logic was invented just to make controllers better. You know, I mean, that's kind of an 80s, 90s thing at this point, but if you've heard of it, someone says, if you want camera controller, watch this. Oh, this is a GDC Talk 50 game camera mistakes. I haven't seen this. So this particular problem is not really it's sort of controller oriented, but yeah, I don't know. Probably some subset of this talk will talk about what we're doing. Okay, let's get YouTube out of our thing. Controllers as in gamepads. No. If you want to know what I mean by controller, look up PD controller or PID controller as well. That's maybe better. And you'll learn all about this. If you went to computer school and you didn't learn what a controller is, maybe you should have gone to a better computer school. That is an industry-wide technical term. I know it's confusing if you're thinking gamepad. This is just the reality that we have of communicating in language. What if you went to math school? Math school, you don't learn about controllers. Okay. So we want to have, we're going to leave our current variables and we'll just delete them later. All right. So overhead T tar per screen. Because there's a lot of things, I tend to be verbose in the way I name my things. Local area T. So these are the interpolants. And then instead of having the target stored on here, I actually compute it per frame because, like I said, you always hang out at a vertex. And so right now this says which vertex are we trying to go to? And I'm not sure. I think we want a different thing, right? I think we want an explicit storage of a toggle that only goes between we want an explicit target that only goes between let's say per screen camera area to overhead target. And we're going to use the same enum, even though this just has this other value. We can change the type of this later. Let's call it enum target just to not confuse it. We're going to have per screen. Actually, let's do this. Per screen var t target, right? Okay, we're going to say no check-in. Make sure to reset these on a new entity manager, etc. Okay. So then we're going to have per screen area to overhead t and per screen var t. Var t. Okay. So like that. These are going to be our things that we update every frame. And the first thing we can do is just do those, right? I mean, we have what happens when the camera teleports and all that. We're not going to worry about that yet. Um, do we actually do that in here, or is it? Yeah. So this move toward function takes the current value, the target value, the current time step, and then rates for going up and down, because um, often I like to have different rates for activate and deactivate, right? Um, yeah. There's various reasons why that feels good to have different rates for activate and deactivate. We've already had way too much explanation. We're not going to do that. Okay. So I'm just going to blindly copy some of this stuff, right? Um, like I said, I'm just going to leave the old stuff in there. We're going to say, um, just, well, far t is easy because we have that as a target. So we're going to go per screen far t, per screen far t target dt rate up, rate down. Okay, that's like literally all we need to do to interpolate that value. Um, you know what? The area to overhead, instead of an enum, let's just make that a t as well. Because it's in the name. We don't need the enum in the value. Because here I was going to check the enums and stuff. Let's just do this. Move toward area to overhead t. So we have the same rates. We can, of course, break this into two different rates or whatever if we want. Okay. Um, well, let's compile that. Let's get rid of this window, please. Okay, so that's great. It's not going to do anything different because we're not ever setting these values and we're not ever using these values. So first, let's try setting the values. Do we do that in player control? What are these called? Per screen. We're going to have to, there's like disabling input based on these values and stuff. This is why I don't want to like delete the old stuff right now, because we'll end up working on irrelevant things, right? Okay. So when we're toggling the local area map, oh God, this is fast travel. Toggle local area. Okay. Wait. Toggle local area. Okay. We can just edit these over here. This is, again, this is other logic to do things. Okay. So overhead control. I don't know why we're getting that. Nobody cares about that anymore. I think that's because we used to use it. Okay. So if camera.far t, well, we wanted to check this, right? No matter what, but we're going to say if camera dot, what did we call it? Per screen far area to overhead t target. So 0 is area. We're just going to write all this out every time. I mean, we could just say, we could just be programmers and just do this, right? So you just say 1 minus. That's a 50 DKP minus. And then if far t is 0, we hard set this. Because like I said, it doesn't matter. Oh, you know what? We got to leave the old things in. So we're still going to toggle these enums even though we don't want to use them because of other code and stuff. And we're going to, when we finish it, we'll get rid of those enums, right? Old version, right? And then same up here. So old version. And, oh, this isn't right. Is it? No, this isn't right. Okay, hold on. I knew I was trying to be too fast. We're not toggling between area and overhead, which is what this would do. We're toggling between area and close. Okay, so unfortunately, it's not this easy. So we're going to go if it's 0, that means we're how do we want to organize? Okay, let's think about this. If far t is 0, we care about far t target, actually. Sorry. So if target is 0, because we want the toggling behavior. If target is 0, that means we're coming in. So you press Q, we want to go out, right? So if target is 0, we are coming in already, or are stationary in the close up position. Else, we are going out already, reverse direction to come in. All right. So, if far t target is 0, obviously we want far t target equals 1, right? Otherwise it equals 0, right? But that's not the only thing that we want to do. If far t target is 1, then we want this. That's why we're not just doing a 1 minus equals 0, because we're going into local area map. And then we're going to do this afterward. We're just going to, same as before, we're going to snap it to the target if and only if far t is 0. Okay. This is where, like, I'm out of brain juice, right? Does this look right to everybody? And then we can copy pasta. Hey, people who are rating. Hello, people. So this is our copy pasta. You could factor these into the same function at some point, because it sure looks like these are almost exactly the same function except for one number, right? So okay. But for now, because they might diverge, and so the way I tend to do this stuff is we just do it and then we'll factor it together if it really is the same function or close or shares a decent amount of code. So if var t target is 0, var t target is 1, and this is 1, I mean, I think this is what we want to do. So this is literally, I mean, the old version code is different as well, which is one reason to leave it factored apart right now. But when this goes away, these are literally the same function except for that number. Right? So that's very easy to factor together if it stays this way. Dude, what? I can't use the UI to ban people. So I have to type it manually. I'm gonna grab some water. Okay. So in theory, we set the values. Who knows? This is per screen, blah, blah, blah. Right? Honestly, I like the name FAR-T better than per screen FAR-T, but it's easy to rename things later if we decide this is too cumbersome. All right, so now it should still do the old behavior. Are we loading into Overworld? Probably. This is debug build, so it takes longer to start up and all these things. Mr. Streamer, why is the game so slow? Because I think we might be building assets differently or something. All right. So it's going to be a lot chunkier, but you know, here we go. Mr. Streamer, why frames? So it still works. We didn't break anything, but we still can get a bounce. It's just harder to see the bounce at this frame rate. Okay. So now there's some structural complications. So remember in the beginning when we started, well, not in the beginning of the stream, but when we started looking at the code, I said the local area T might not be initialized, right? And we of course need it to be initialized. And so there's an init camera prior to interpolation that does some of this stuff for historical reasons. I was going to factor this back into the code that we're using, so it's in the same function, but it does a little bit of other stuff too. And like I wanted to have a sundae today, so I didn't do it. I don't mean an ice cream sundae. That would have been good too. Okay. So here we have a variable doing local area view I actually don't know why we're setting this. Anyway. Wait, this is... How did I end up here? Prior to... I wanted to be here. So, um... I guess this doesn't... I searched for that variable check. Here we have a thing called local area view. This is a little slightly sketch. It's just saying, look, initialize this if this is our target. If this is not our target, we stop updating it, but it lives in some variables, right? So here I'm going to say, this code has been giving me headaches, by the way. Like all the other interpolation stuff is yeah. So here we're just clearing out the value if we don't think we need it and whatever. All right. There might be better ways to phrase this. This is part of the old code that we're now going to overwrite. So here we're going to say if local area view, well, actually, no, we're going to say, we want to set, we just want to change this, right? So we want, this is just a Boolean that we're using locally. Should we update this? And we're going to say camera dot local per screen. Is it area to overhead target is equal to 0? So, and, well, no, let's do that. Let's just do that. Okay. Well, does that compile? No. What? I got it wrong. Per screen area. Oh, it's T target. Okay. This still won't do anything that we want. In fact, it'll be broken now because we took this out. But yeah, okay. So now we go down here to the interpolations. We're going to want, we want to animate far T. Wait, where is that? We already did that. Far T target. Move toward. So that's at line 13. That's a few hundred lines above where we are. It's in the same function though. It's a big chunky function. So we update these. This is some Z interpolation that's a different thing for the close-up view. Okay, and then orthographic T. Okay, well this is a different thing now. So one of my worries is because we're doing this thing where we're leaving old code around, we're going to have bugs due to if statements based on the old code and stuff. I'm trying to thread that needle right now of like not rat holing on stuff that doesn't matter to the discussion, but it might be what derails us, honestly. So here we're going to say if camera dot per screen bar T is greater than 0. So orthographic t was a value that we made that was sort of like the max of the area t and the overhead t. And you know what we actually could do? We can change this. So let's just redefine these with the same name, which also is fraught with peril, but let's just see. So camera.per_screen var t. Okay, because we're not using those anymore. All right. Wait. I messed up. Oh no. That's fine. No, did I mess up? Yeah. So overhead t is a different thing. It's just my brain put overhead and orthographic together. We don't want to mess with this. We want this. But we do, this is the other thing that was confusing. Okay. Camera ease. Ease. All right. How bad did I screw that up? Not at all. Well, not at all in terms of compiling. Okay, so now, instead of these interpolations, which we're going to completely comment out, both of them. Oh my God, look at all that crap. What's going on in there? All right. Oh, okay. Actually, those parts, those are not, even though it said the interpolations, these aren't the interpolations yet, thankfully. These are just computing the positions we're interpolating toward. All that stays the same, except I want to check for orthographic t, because I don't think we want it. Orthographic t. Okay. Yeah. So another trick in programming is like, oh, I guess we use it there. I was going to say you want to define things close to where you use them. Okay. So here we go. So instead of this, and instead of this, I mean, this has nothing to do with the interpolations. We actually, put that there because we were using this value a little bit, but then we stopped using that value. All right. Okay. So we're going to have a check because, like I said, this might not be initialized, but if we're going to use this in interpolation, it had better be initialized, right? So camera.per_screen dude, the typing tonight. Okay, that's just gonna, what are the odds of this going off? 90% till we fix things. Because I'm kind of tired. All right, so It is now 11 p.m. almost. So that's what's going on. Okay. So we're just going to log an error there. So now we're going to say var viewpoint equals lerp viewpoint or lerp. Let's just say far pause. Encounter at far pause, the famous episode of Star Trek. Is lerp pause area pause overhead area to overhead t. This is interpolating viewpoint. I don't love that. This is already. Yeah, I guess this is fine. I don't know. Let's see. Things always get a little complicated with. So dy is this linear slice of how much of the map do we want to see? All right. I don't know why these are called override dy. That's weird. Dy var dy equals lerp area override dy overhead override dy area to overhead t. All right, and then look at is the same. Var look at is lerp area look at overhead look at area to overhead t. All right. Right? Something like that. Okay. And then viewpoint equals lerp viewpoint var pause var t. Actually, we want these to be the easing function, right? So this should be orthographic tt. Right? And this is, I don't remember if we defined var tt. I don't think we did. We'll check in a second. Dy equals lerp dy var tt look at equals lerp look at var look at var tt. Okay, and then there's this other variable that's used by the shaders, this camera.area ortho distance, and we're just gonna set that there. Okay, like I said, I don't think we have a var tt. We don't. Wait, that is orthographic tt. Okay, wait. I got it right. So we don't want to use orthographic tt for the first interpolation. We want to use area to overhead. We want the first thing I typed. All right. Dear Chat GPT, please clod the first cursor I typed. Okay. So this is, we should probably call it var tt later. Again, it's easy to rename things. Because you want, like, why is this called orthographic all of a sudden? It's historical. It's historical. That's like a line from Hamilton or something. All right. How much of a disaster is it? How many bugs? Do we even see our character when we start is the question. I feel like the camera is like way off to the side. It probably was. Okay. Hey, we see our character. That's great. What if I hit Q? Hey, that works. What if I hit tab? Hey, that works. What if I hit tab and then I hit Q? Okay, that did the wrong thing. That did the wrong thing. What if I hit Q and then hit tab? Wrong thing. Okay, so like I said, I don't have enough brain juice. So if we're here, okay. Yeah, we're assuming that there's no, all right. Let's just do one of them, okay? If we're on Q, again, when you have no brain juice at all, don't try to be maximally general. Just get very specific and be like, what do I need to do to solve my exact problem? That's also why we left these. It's one of the many reasons why we left these factored apart. I want to solve the problem. I'm in, when I press Q, I can be in one of three places. I'm only handling two of the places here. I am handling close-up view, okay? Here, well, if we are in, if we are going out to overhead map mode, oh, if we are in local area map mode, reverse direction to come in. Otherwise, switch from overhead mode to local area mode. Let's call this local area mode, right? So if camera dot area to overhead T target is equal to 0, that's area, right? 0 is area, 1 is overhead, which is why this is called this. So if that's 0, do this, right? Otherwise, we don't touch that value, but we say assign it to 0. All right. And we're just going to test that. This is called per screen. I err on the side of verbose names, and sometimes they're too verbose. But like when you're working, there's a whole other camera mode in the game that's about cycling around to different viewpoints on levels that behave differently than this. And that's why there's these prefixes, because there's a whole other camera behavior. All right. So what did we do? We said Q. We're just going to test this still works. All right. So we said, wait, we said, what if we press Q, but we're in tab? So tab, and then what if we press Q? Hey, it went to the right place. Right? And, oh, that didn't work. Okay, honestly, we might want to swap the order of the if statements. Right? So if we're here and we press Q, we come close. Wait, that's correct. Hold on. That's correct. We're here. We press Q, we come close. We press Q again. We press Q again. Maybe I got confused. This looks right to me. And we're not allowed to say, what if we're here and we press tab? Because we didn't edit that function yet. Right? So we need to go edit this function. And it's probably copy pasta of literally the same thing, right? So we probably still are going to want to factor these together, but let's see. So we're coming in already, or stationary in the close-up position. Here we go 1 for overhead, right? If we are in local area mode, switch to overhead mode. Otherwise, come back into close mode. All right. So if we're in local area mode, switch to overhead mode, right? Otherwise, come back to close mode. Okay. So if this works okay, then we'll spend 500 minutes compiling a release build because LLVM's so slow. And then we'll see if we get bounces, right? Because that was the whole point, is like, we're trying to avoid bounces. What's going to happen? All right, so tab, Q, 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 tab, 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 Q. Now tab should bring us back out. Tab. Hey. Now tab should bring us back in. Q, tab, Q, tab, tab, Q, Q. Okay, this is fine. Let's try the middle. Tab, I'm going to go tab Q. Ready? Tab Q. Q tab. Let's slow it down a bit. We'll see if we can see a bounce in debug mode, but Q tab. Tab. Tab Q. Q tab. I mean, it looks pretty good. Tab, tab. Tab Q. So that was a little interesting. There was a little bit of a bounce there, the tab Q from far out. But like, that seems like a less objectionable bounce to me. Tab Q. There is a little bit of a bounce. That's interesting. I thought there wouldn't be any, but there is one. Yeah, I mean, the thing is, I like it better stylistically than the other bounce. Oh, look. Remember when I said the probability of this was high? It's happening, but I think it's only happening very rarely, and we're not. I'll debug this on an offline session because I would like to go to bed tonight, but it's not happening like every frame or anything. My assumption is this is happening on the first frame where you start at 0, but then you're going toward 1. Maybe that's when that's happening, because you know what? I bet that's remember this thing that we did? I control C this for a second. So the target, wait. So the target could be 0 or non-zero, but we're still interpolating that way, right? So yeah. I hope I didn't break it too bad, but we're going to do release build. Somebody is already in bed. I'm sure lots of people around the world are already in bed, honestly. So, how's it going, everybody? It's interesting that it does still bounce. I'm kind of not sure why. This might be a thing. Again, I want to go to bed, but when you see a bounce like that, thing number one is like, are you really doing what you thought you were with the interpolation variables? So we can just log those, right? I guess it makes sense that there's a bounce. But the location of the bounce is different. And yeah, like I said, maybe that makes it feel better. The bounce is also smaller in magnitude, I think. Can't get to bed if things are still bouncing. Sometimes you have to go to bed even when things are still bouncing. Ah. Tomorrow we might put together the rack stream. I have fancy ideas about how to make our machine room frickin' bearable. So we'll see how that is. All right. So the outlines are a little late fading in, but that's probably something we can deal with. All right. So what did we do? We did tab Q. I actually don't love that bounce when we're going this fast. Maybe it's not better. Maybe this whole stream has been for naught. It is better. Okay, it's better. Let me put it this way though. It's better, but I'm not satisfied with it. So maybe we got to do something else. Like at low frame rates, it didn't seem that bad, but at high frame rates, I don't like it. So that's how you know that this stream is legit and not fake. Like I went for a whole hour explaining what I was going to do and why it was a good idea, and then it didn't solve the problem in the way I thought. Unless, okay, there could just be a bug. It could be that mathematically we're better, but there's a bug, maybe. Let's do slow version. Tab Q. See that? How is that possible? How are we going out? That's what I don't understand. Maybe we're not going out. Maybe it's the FOV. We're going to have to graph this. We're going to do a follow-up stream where we graph this to figure out what's going on. Because I don't understand. Okay, going back to this. Okay, if we're here, this is far, this is like medium, right? And this is close. If we're going linearly from far to medium, well, okay, let's say exactly what we were doing. We were at fully out, okay, and then we hit tab, which means we started going in this way, right? Oh, I guess I get it. And then we hit Q. Q says, no, we want to go here. So we're arcing up to go there, right? So our path through the triangle is like that somehow. Uh, it's this is a little misleading because it's gonna be like asymptotic to this until the final vertex, right? So I guess I see how that could bounce. Now, one thing is the magnitude of the bounce and all that is proportional to the various timings that we have, right? And so we could tweak the timings within reason. But yeah, I don't love it. I don't love it. This is just how it is sometimes. At least we did the work tonight, right? We're like, okay, so now it's the next step. Now it's like, all right, we tried this thing. It didn't do what I hoped. And I guess I see why. So, like, what's the next step? And so, again, first next step is debug. And then next step after that is try to figure out, maybe we got to go dynamic. For all the bad mouthing I did of how I don't want to do a controller, maybe we have to do a controller, right? Or there's a static version of a controller, which is like you heuristically pick, like I said, the speed and maybe the starting point on the ease curve and all that stuff. Because you don't, yeah, it's complicated, but you could heuristically pick those things depending on where you start. I don't love that because that's probably pretty hard to visualize and pretty hard to tune. But if it's what we have to do, then it's what we have to do. I don't know. But we got to the next step. That's great. We had a 2-hour stream. I mean, if I were just programming this, it would have been half an hour or less, right? But like all the explanation and all these things padded it out. So this is programming sometimes, right? It's like, oh, okay, maybe there's no way to get around. Like it's quite possible that if you're in a triangle, there's no realistic way to avoid a bounce and you have to go to a higher dimensional shape or something, right? You could write out mathematically what the requirement is to not bounce, right? So you could write it based on our interpolation functions. Um, so the new ones are do there's so much code. This is prior to interpolation, of course. Okay. So oh yeah, that's figuring out the endpoints. Here's the actual interpolations again. So here, um, there's a distance to this far pause or pause overhead, right? And sorry, pause area and pause overhead, right? Those are essentially at different distances, I think along the same vector as each other, but we could check that, right? Um, so we have a position that first we interpolate between these, and then we interpolate. Viewpoint is the close-up view, and we interpolate between these. At least I believe so. there's some old code crawling through here. So again, part of debugging will be validating that what we think we're doing is what we're actually doing, right? Um, but so, if these are all the look at point plus some vector each, you could reformulate this interpolation. Instead of interpolating vectors in space, you interpolate a scalar that's like how far along the look at vector do you go? Except I just don't think I don't think they're all in a line like that. But anyway, if it were, so the whole thing I'm trying to say is if they were in a line like that, you could just take that distance and you could write the constraint on some graphing tool or whatever. The distance doesn't go down or doesn't go up. If you're out and distance is high and you're going in so that distance is low, you don't want distance to come back up before it goes down again, right? You don't want a hump in your distance function. And so if you were to graph this, every point in this thing, you could color with like a heat map according to how far it is. And then you would want this path to be monotonic in those colors. And the question is that possible? What does that look like? Can we guarantee that for any starting point along here? I don't know. The derivative should never be zero in the middle of the path. Yes, that's like Rawls' theorem or whatever, right? Um, Raleigh's. Rollo. He invented the Rollo candy. Actually, Rollo Tomasi invented the Rollo candy. Anyway, so yes. But there's a difference between trying to solve that by eyeballing it, trying to solve it analytically, and using that analytical solve to find some code that will let you, do this at runtime. So it's just something I need to think about and look at. But I'm glad we did this experiment. It did not go as planned. We're going to put this on YouTube under the title It Did Not Go As Planned because I think that's valuable. I think it's valuable for people to see how these things go. Maybe somebody will see it who's super good at interpolation and they'll say, actually, you just do the Flippenbacher maneuver and it will always be monotonic. That would be great. It's interesting. So straight lines across this triangle are monotonic by definition, I think. Yeah, they can't not be, right? Because 3 points determine a triangle. This is something that I remember from the old days of writing your own texture mapper. 3 points determine a triangle in this 2D space of the graph, right? But then 3 points also determine a triangle in um, in the 3D space of where we're putting these points. So we're planar in the graph and we're planar and linear in the graph and well, I guess that's redundant, I guess. And we're planar in space. And so there's a transform that takes one triangle to the other triangle that's linear. So it's all monotonic if it's a straight line. And the issue here is we're not doing a straight line. We're starting in and then going out. And the question is, how do we avoid this? And probably the answer is you just don't go as far in as fast, right? Like if this is non-monotonic, pick a different color. Maybe like this is monotonic. You know, at some point, something along here is monotonic because the straight line is monotonic, right? So maybe this is, that's the thing I don't know is like where, maybe it's only if you cross the barycenter of the triangle. Is that the case? I don't know. That's a random, since we were talking about barycenters earlier, that's a random idea. Maybe if you don't cross this, you're fine. I don't know. I don't know enough about these things. Yeah, wait until you see what actually happened. I can put some title on that, and then the video could be my face going like, or whatever, right? Because that's what you do if you're a YouTuber. All right, everybody. I'm going to sign off and go to bed. Thanks for hanging out tonight. I was glad that we did, you know, an organized thing again, because we haven't done those too much lately. And we'll see. We'll see how we solve this problem, and we'll post a follow-up. Thanks, everyone. Have a good night.